Okay, I'll turn it over to Mike Frank of Gazzang, who's going to talk to us about transparent encryption with MySQL and Easy Encrypt.
All right, thanks for having me. Oops. Oh, it's showing up. Oh,
there you go.
Weird. All right. So today, let's see which screen I got on. Today I'd like to talk a bit about what I call transparent encryption and how it works with MySQL. So basically, you know, we're here to talk about MySQL, about data, about encryption. I want to talk about why you need to encrypt, why a little bit of fear is an important thing, some ways that data gets leaked out that you might not be considering. I want to talk about what our product Easy Encrypt does for MySQL, how it creates this transparent encryption, and how there may be more to it than maybe you think. And then technically I'm going to show you, I'm going to go into what the product does, how it works, what it's like in your environment. I'm going to talk about some of the folks that are using the product and what the business problems they're using to solve with it. And then I've got a what's next, sort of a cool development we've got about some new techniques with the product that I think are interesting. So I just want to share that with the group since they'll be out in about 3 weeks. So I'm VP of Products at Gazzang. Formerly I was at MySQL for about 3 years, so pretty up on that. And then prior to that, I worked with SQL Server, I worked with Oracle, I worked with all kinds of databases at Idera, at NetIQ, at Intersoft doing trading systems with Oracle as a backend, at Landmark Graphics. So, you know, been doing this a while. Gazzang is a startup. It's based out of Austin, although I'm out of Houston. The technology's been developed, probably under development for a little over 2 years. We're really trying to enable the cloud, trying to bring security to the cloud and secure things. And we're really focused on practitioners. So these are tools for practitioners. They're set up to use as tools. They're priced so that folks can easily get hold of them. So that's sort of our goal there. So MySQL, right, has got a lot of data in it, and it's got a lot of applications and data around it. And so, you know, when you look at things are stored, you know, in Linux more and more. It's being, you know, in the cloud. Linux is really the most common operating system you find out there. So this whole LAMP stack, this whole MySQL and the data in it is really what you find that's there. And there's more and more, I think, you know, what I've seen over the last 2 years with MySQL, there's more data that's personal, there's more data that's healthcare, there's more data that's financial. So MySQL is really evolving into more enterprise type of systems where there's data that really you might want to protect. So it's getting more enterprisey. But, you know, data's getting out there, and so one, you don't want to lose your data, you don't want people capturing it, and I'll talk about some ways that they do that. And then there's just plain compliance requirements for businesses that you have to follow, whether that's HIPAA, whether that's some sort of FIPS type stuff, whether that's Sarbanes-Oxley, or, you know, all those type of requirements that you get from high tech, from PCI, for any sort of stuff with e-commerce. So, you know, it's important to be able to do that type of thing. Also, and I'm going to expand this because I cannot see it, so. Also, you know, a lot of times folks, I think, maybe have a little bit of false sense of security about how secure their data might be. Sometimes that's the case. Sometimes it's a case where you as DBAs know that maybe there's a little bit of shakiness on the data, but, you know, you can't convince managers. Or some of the guys may be totally, you know, security-oriented DBAs, and I think we see people all across the range. I don't know, how many of y'all consider yourselves sort of security zealots or really drive that home? You know, we got a few out there. And I think that's becoming more common nowadays. And it's important to the job as a DBA to have that sort of mindset. So, transparent encryption, my simple-minded definition of it is really, it's a process or framework that allows encryption and access controls and key management for a process or a script without that process or that script knowing it. So it's transparent. So it magically is able to encrypt and decrypt data. It has the attributes that you get from encryption, from key management, from added access controls. But you didn't have to recode it. You didn't have to make any changes to it. And in particular, we're talking about MySQL here. So this will go into MySQL. MySQL doesn't really have any concept that encryption is being done for it. It just happens transparently. And I'll explain how that's done. Also, around encrypting data. There's data that we think of in tables or in indexes, but it's also other data. It's data about data. It's in properties files, it's in configuration files, it's in logs, it's in all kinds of different places. So really, you sort of have to get your head about where is all my data? Where might it escape from me? It's not just, the tables per se. But the problem with encryption really has been that it's sort of complicated. And a lot of times when you try to write it on your own, public key stuff, hiding the key, managing the key, writing encryption and decryption functions, making them fast, it's a lot of work. And so really, and a lot of times it's very specific to a certain workflow. And so with the goal of transparent encryption is really to say, okay, here's a methodology we can use, and we don't have to worry about having a specific amount of code written for every single workflow I come up with. So maybe I'll apply this thing more generically. Also, a lot of times you don't have control of the code. You're using third-party code. It's MySQL code or it's some third-party product that maybe doesn't have the level of security or level of encryption that you need. So this comes in, and it's non-disruptive. Really, complexity is sort of the enemy of security, because when security gets too complex, people quit doing it. So you sort of lose some of those type of things when you get too complicated. And so part of our thing that I'm trying to do with the product at Gazzang is really to make it simple, to make it easy to deploy, to make folks get up and going in minutes. So we're solving problems, again, with PCI, with HIPAA, with FISMA. We're solving problems of key management. We're solving problems with protecting applications. And oftentimes too, a lot of the open source folks aren't the most oriented toward really doing all the sort of security within their products. They look at things more in a layered approach. And so this, you can maybe think of this as a different layer to come in there. So on the Linux side, right, so when we're looking at Linux, where are the exposures, where are the risks? Well, one, Linux users in general, and certainly root just has all these privileges. And certainly there are things like, SE Linux or Apple that you can put in place. A lot of people really have trouble making those things work properly in a lot of environments. But, they're there to really add access controls. On the other side too, right, so you've got these files that are in the file system. If you steal these files, the files that are underneath MySQL, you've really got the data. So even though you may have MySQL well locked down from a service side, you may not have the level of protection you really need to do the separation of duties between somebody that's an administrator on the system. And more in these systems, and especially if you're developing like a SaaS type of system where you're hosting other people's data, being able to do a more finer grained segregation of duty has really become more important for a lot of those types of plays. So if you're doing one of those, it's important. We can gather data on the network. We can gather data through virtual images, through clones, those type of things, and I'll talk about how to protect against that. And then, there's just other ways to get to storage, and then just plain stealing disks. So we've seen that kind of thing happen. So on the MySQL, the important data is in many places. So mainly, right, we're looking at storage engines like InnoDB and MySQL. And it could be other storage engines, ExtraDB or Tokyo or InfoBright. It could be in logs, so query logs have data in them. Binary logs have data in them. If we can copy those files off somewhere else, tools that we can operate on, or some of it's just in clear text, we can gather that data. So really, we're trying to prevent those things from escaping and being used by somebody that doesn't really have access. It can be, yes, sir.
My.user, it means that MySQL.user, the privileges database?
No, so in this case, we're talking about the operating system user. So transparent encryption assumes that you're going to have in place the proper access controls within the database, but you're really protecting the data outside the database processes.
Right. So usually the username is MySQL and the group is MySQL. Is that what you mean?
Yeah, so it would be the operating system user that's MySQL, or the root user on the operating system, or other users that for some reason it could be backup users that have rights to copy files. All those types of users do have access to the data if it's not encrypted. Also, right, if the configuration files aren't encrypted, right, there's certain usernames and passwords that allow me to log in. I may be using those for replication. I may be using those for other client applications. I'll give an example later on MySQL dump about how we might be able to protect the username and the password for MySQL dump used to make our backups, and also how we might protect our backup files themselves. And then I got ahead of myself, and certainly backup files exports, right? So if you get a copy of the backup, you've got the data. So you can't forget about any of these things. And like on the backups in particular, there's a lot of these managed services out there in the cloud or in these different places. And really, you do want those managed service providers to be doing things like backups for you. But quite honestly, you want them to run them, you want them to store them, but you don't want to have access to the data in them. So it's things like that. So in MySQL, right, we've got certain directories where data is stored. So var live MySQL, where my data is. I've got temp directories where data might go. I've got where my InnoDB data might go. So these are directories where files go in, and we might want to protect them. And then, in particular, on InnoDB2, we can do per table spaces where it's just all in one place. And in some ways that's better, and also in some ways it directs the user more specifically to what data they may want to go steal if they're a thief or something like that. The other stuff too is, right, so we're trying to protect the database, but to your point, so MySQL does have users. You have to use those users to get in. And so if the applications, if this ecosystem that's accessing MySQL isn't well protected, so your security is only as strong as the weakest link. And so if my PHP code or my Java code or my whatever code I've got exposes these logins to where somebody can just go get those, then I've still got a hole. And also just talking about data itself. So I've got data that, like a credit card number. So it may be obvious that, hey, I'm going to go use an encryption function on that. Maybe I encrypt it in my application. Maybe I encrypt it in MySQL. But then there's other data that if it gets leaked out that I may not necessarily encrypt, but I still don't want it leaking out. So we've had all these problems where everybody's email got we all got these emails to our email accounts where your account's been released. That there have been some hackers get into those type of things. So I don't want really anybody to know my my name, my email address, my phone number. I don't want any of that personal information getting out. But there have been lots of cases of that happening. So it may be that you still encrypt credit card numbers directly, and you probably will. But there's all this other data that's of value that if you encrypted it, now it's not searchable. You run into all these problems if you do that. Or it's an application where really doesn't allow you to go in and do that yourself because it's third party or something like that. In Java, it's easy to reverse engineer it. You can see that information. Libraries, you may need to protect those from tainting. It's not that hard to replace some shared libraries. You might want to protect those. Just the configuration files for applications themselves, and certainly logs from applications accessing MySQL. So you got to sort of think of the whole ecosystem. And so I'm talking about MySQL here, but I'm also talking about how transparent encryption can protect the whole LAMP stack or the whole sort of Linux set of applications. So in Apache, we're looking at flat files, we're looking at scripts and code we're trying to protect. And again, that code might have intellectual property in it, but it also has provides means to access into my database. So this could be in property files, in bin files, logs, different things like that. So how are we doing this? So it's sort of, there's multiple parts really to how you solve this problem. The first part is that you want to encrypt the data. And so if the data is encrypted, then it protects things from theft, right? If somebody steals a file, AES-256, it's just junk. So, but the problem with that is that it doesn't necessarily, a lot of the methods that are used out there, right, they're down at the disk level. And so still at the operating system level, okay, somebody steals a disk, it's junk. But if they get into my OS, if they get into my server, the data's typically there in the file system as regular data. But that's part of the solution is encrypting it. But then, so say I want to get around that, I really want to limit access. So MySQL should only get access to the MySQL files. Other things have no need for it, they shouldn't get to it. And so the other thing is, so part two is, okay, I'm gonna improve my access controls. I'm not going to let operating system users or processes on the system that shouldn't have access. I'm going to prevent them from having access to that. So that's great, but there's still ways to, but the data's not encrypted, or I can't protect the data still at the level I need to, and there still may be a way to get around that. But then there's a third part to that too, right? So all data that's encrypted, there's got to be a key for it, the RSA key or a long passphrase and assault or whatever, something to go into the encryption. And so I need a safe place to store it. I can't just put it, it's not, I can't put it under the doormat to my house and expect somebody not to figure out that the key's under the doormat opening the door. And way too many designs and solutions for encryption fall into that category. And you see news releases out there and they go, well, the data was encrypted, but they're kind of, you can see they're hemming and hawing because they figure that whoever stole it probably also was able to get access to the key. And so you need a safe place to store it off the system, to put it, and in this case we're talking about putting it in a safe key ring in Linux memory. Obviously you can get even further, you can get into hardware solutions and stuff like that. It really depends on the level of security that you need, whether you need the sealed tamper-proof box or if you need something that's in a key ring is safe enough or not. So my proposal is that 1, 2, 3 really leads to the solution. So that leads to what I would call transparent encryption. So we're encrypting, we're controlling access, we're managing keys, and it's kind of like firewalls or whitelists in a way. So instead of a client going through this protocol to get to this particular server, we're really saying I got this application that is allowed to get to this part of the data files on my file system, and we're going to do that through encryption and key control and access controls to allow it to do that. So that's sort of how it brings it all together. That's sort of how we build this transparent encryption. Also, the other nice side of that is that when we're doing this, we're also looking at when things come in to try to access the file system. And so when somebody that shouldn't get access to it tries to get access, then we can note that there was an access control failure. And then you can do all kinds of fun alerting on that type of thing in a much finer grained sense than you might be able to do just on basic operating system user permission type stuff. That makes sense? So when we started out at Gazzang, we built a product for MySQL. And what we really, we were encrypting all the data from MySQL, and it was shrink wrapped and stuff like that. But what we really discovered, and what I've talked about a bit here, is that really there's more of an ecosystem around that. So it's an ecosystem around data files coming in, data files getting loaded into MySQL, protecting the data once it's in MySQL, protecting the data as it gets backed up, trying to differentiate duties based on those different levels of tasks. And so what we did really was come up with a product where you could, one, we would come in, we can shrink wrap encryption rules around MySQL, but then these other things, these other tasks that may be specific, we can create rules for those as well. And so we can create a whole secure environment for MySQL around all those different tasks sort of in the life cycle of the data as it comes in, lives, gets backed up and archived. And it also allows us to really support other stacks. And so, you know, it's not MySQL alone, it's these other applications, it may be other open source databases as well. And often these things get used in combinations depending on whether we're doing business analysis or whether we're doing transactions. It depends what we're doing and what type of thing we're supporting. So we really tried to sort of liberate this thing out, create these sort of firewall type rules so that folks could go in and create sort of any type of transparent encryption they needed. So basically the way it works is that we come in to Linux and we have a virtual file system that sits on top of the operating system. And so operating system's file system. So we don't really care which file system it is. So it could be Riser FS, it could be XT2 or 3 or 4 or whatever you might be running. We don't really care what that is. And we don't really care if the data is in place already as well. So it's not one of these type of solutions where, because it's a virtual file system, I didn't have to install it, I didn't have to configure a disk, do all this type of stuff from the get-go. So I can go into existing systems and easily put this in place. And so we've got access control that looks at processes. So the way it works is basically I'm looking at a process and I'm looking at its name, owner, location. I'm doing a SHA 256 hash of the thing. And when it comes into the file system, I'm saying, okay, you know, does your fingerprint map, are you who I think you are? If yes, you are, then it's like, okay, you're cool, your access control maps to this part of the file system, so it may be like the MySQL data category, and I know where the MySQL data is. And so then from there, I say, well, if you're getting the MySQL data, then you're allowed to have the key. So the process comes in, fingerprint it, it matches, you're cool, okay, you get the key so that you can do AES 256 encryption and decryption as you run. But if anything else comes in, you know, if they're not in my list of access controls, if they're not in my whitelist, then they're not allowed to get to that data. And this is all transparent to this, whatever this Linux executable might be. And it's not limited to one executable, so you have the MySQL but you may have some other backup things that need to get to the files. And so you can put in trust for those type of things like an extra backup or MySQL Enterprise backup where, right, those are really getting to the raw files themselves, and you can set up rules for those easily. The other part of this thing too is, okay, so like I said, the key needs to go off somewhere else. And so we've got a trusted key store that basically allows somebody to set up the system. You're going to create a passphrase, or you're going to use a RSA key. That goes in, we're going to take and we're going to push that into the key server, and we're going to use SSL, and we're going to use one-time passwords that constantly change. And by the way, those type of things, we can detect clones of virtual servers and all kinds of things like that. And so it's strong, but at the same time it supports some of the flexibility you have to have if you're implementing MySQL on cloud servers or on your own private cloud or virtual servers and things like that. So it's pushing the key, it's storing it out safely, it's fingerprinting that box, that server where it's coming from, so that then it can basically go out and retrieve it. So when the server boots up, it's going to come up, it's going to call this service, it's going to say, you know, I'd like to get my key. I've got the one-time secret. Okay, it matches up. If it didn't match up, then we would know, hey, this may be an imposter, or it may be a clone, because the clone's going to be out of sync with one-time passwords changing continuously. And then I'm going to extract that key. I'm going to bring it back. I'm going to load it in, and I'm going to start up this virtual file system, and I'm going to put that key in the key ring so it can use it. And what's nice about that too is that it's very robust. So if that key server goes down, I'm okay. I've got it in my key ring. I've got it stored in my server locally. You know, network disruption, any of that type of thing. We're not relying on constant, real chatty talk with a key storage server to get that thing continuously. And I can do it across clouds. I can do it across servers. I can do it in my enterprise and in the cloud. There may be cases where I want to share a similar RSA key or passphrase and solve. So that lets me do that. So system-wise, so we don't run on Windows. We're specifically on Linux. We run on 2.6.19 kernel and above, or on Red Hat. The numbering's a little bit different. It's 2.6.18-192 and above. So it's those above, and all the major distributions. So Red Hat, CentOS, even things like Cloud Linux. You know, so we've got, it's very portable type of stuff. Works on virtual servers, works on the cloud, works with dynamic IP addresses and things like that where it changes. It's easily deployable, so if you're running RightScale, if you're running Puppet, if you're, you know, creating recipes with whatever, you can easily automate this thing to span out and share keys across lots of servers, because, right, you know, we may have one master and we're cloning up slaves as we scale up systems, but we still want to protect the data with the same encryption keys. So we can do that kind of thing. And, you know, protecting data across these highly replicated systems is, you know, is an extra challenge that I think folks face. Are any of you guys, how many folks in here are running replication? Yeah. Yeah, and so, you know, I think you can understand what I'm saying. And also on the replication side too, there's that whole setup and creating a new slave, and how do I do that securely, and how do I sort of bootstrap the thing. So there's that part of this thing. On the Linux kernels and dependencies, we've got a few, you know, we're not reinventing the wheels with the tools for some of this encryption stuff, some of the security stuff. So this is just a list of the requirements that we have. When we come in and install the product, we look to see if they're there. If they're not there, we'll install them for you automatically. But it's a fairly short list, really. So how does it work? So, and I guess let me switch to a demo mode now. All right. So on the system, we're running as a kernel module. And so if you do a PS, you know, you're not going to see us in the process tables. But you can tell if we're started up, basically. You know, by running a status sync. So we're in there, we're running inside the kernel. Again, we're using the Linux virtual file system methodology. Now, I've got MySQL running here, and I put the world database in there. And if I go to so I can see that where I would normally see world, I've got a soft link and it's going to var lib easy encrypted MySQL. It's set up that way because I went in and I ran a simple command easy encrypt -e or easy encrypt -mysql -e world, and I said encrypt all the tables in world. Now I could have gone in, I could have done a wildcard, I could have picked particular tables. I happen to have done them all. So that database, that file, all those files are now encrypted in AES 256. And if anything tries to get to them, and for example, I tried to get to it earlier as root, and I just tried to list out the files that were in there. And basically it'll throw an access denied. So any process trying to get into there won't be able to get into there. But you know, if I'm in, you know, so all that data is transparently, it's encrypted. It's encrypted on the file system, but these files are, you know, it looks normal to MySQL. So MySQL doesn't know that this encryption is there. But as I showed you, root can't get to the data. It's all AES 256. There's access controls around getting to the data. So that's why we call it transparent encryption. You know, so the other cool thing too is that if for some reason you wanted to, say there was some reason that you needed to work as a session where you had full access to the files as if they were unencrypted, and you had possession of the passphrase and salt or the RSA key and the password for it, then you can actually go in and set up the session. So I can actually set session, and then now all the files will look unencrypted. So you can basically do transparent encryption for a whole session. So if there are cases where you need to go in, sleuth, look at the files, stuff like that, if you indeed are the person that has permission, then you can do that. But the person that has root, that works at, you know, cloud, managed cloud server company X, wouldn't be able to get into that because they're not going to know your passphrase and salt. They're not going to have your RSA key or anything like that. Yes?
So are you talking about like a bash session, or are you talking about like the
like
files are still transparent, it's just within that process?
So I can set it session-wise. So it could be a bash session, it could be for programs, it could be for really for anything.
Okay. But it's not like a time thing where like you're unlocking to everything.
So you can set a user session or you can set a session. Right now we just support session, and then so you turn your session on and off. We're also going to add a little option where you can say for this user session, so it's only limited to a certain you know, window shell that you're in. But yeah, that's a good question, and that's kind of a comforting thing to have because one, you know, it gives you the flexibility to work as a normal system administrator the way you're used to, and you don't have to think about this stuff if you do need to go in and do some sleuthing. Or, you know, if for some reason you wanted to back out of this, right, it's not that hard to do because you can go in, set session, you can get everything decrypted, you know, instantly. It's you know, that's not tricky, and so it's really, you know, that's pretty straightforward. So let's see what else. So these are sort of the list of commands that we have. So we have this access control command, and I'll show you how that works in a second. Change keys, so sometimes we don't rotate out keys. And we've got a cool way too that you can, say you've got terabytes of data, right? But you've got a key rotation requirement, right? And a lot of these regulations out there have those.
You mean like every 30 days change the key, every 90 days change the key?
Right, yeah. So how am I going to do that on 10 terabytes of data. It's not going to happen, or I can't do that through normal traditional methods where I encrypt all the data and then I got to change the key, I got to decrypt all the data, I got to re-encrypt all the data, and by the way, while I'm doing that, I'm exposing all the data. It's a bad thing. What you can do with this product is you can actually rotate, you're really rotating out a master key. And so there's a secret master key that encrypts the knowledge about how to decrypt all that data. And so basically, you can just re-encrypt that small file there. All the secrets about how all your data is encrypted on a per file basis still remain secret, but I can rotate the key out to where that still is the only key that can be used to encrypt and decrypt. So it's a nice way, if you've got multi-terabytes of data that you've got encrypted, that you don't have to go through and just totally re-encrypt and decrypt the whole system, which is, a big pain. So that, that's kind of a unique thing that we offer, and a lot of people struggle with that once they get to large volumes of data, in that, I've got to schedule unencrypting and re-encrypting all my data because my key has to change every 30 days or 90 days. We've got things where you can check the key. Yes, sir.
Can you kind of explain? I don't really see why having a master key would, because what if someone gets the master key?
So the master key stays secret, and it's hidden in this AS256 encrypted file.
Okay.
So it's the only way you can. Yeah. So you would have to be able to have the means to
actually go and get the physical key or something.
Yeah.
Okay.
Yeah. So again, it's a way to ultimately, provide a limited way for a key that can expire and change over time. I mean, some folks may say that, well, for our systems that's not acceptable. We need to unencrypt and re-encrypt 10 terabytes of data every 30 days. And if that's what they need to do, that's fine. But this is another way, really, because we're really trying to change the access control on the file if somebody leaves the company, or for various reasons, so that knowledge of that key changes over time.
Okay.
It's just it's another way of doing it. It's another indirection. Security is all built in layers, and so that may not ultimately be as secure, but it's pretty darn good, and it beats having to unencrypt the data and expose it that way as well. Because no matter what, you're going to have to, you're going to have to flip that out, and you may not have the disk space to do some of these type of things, or it's just a high availability system, and you just can't bring it down. So once it's encrypted, it's just got to stay up and running, and you can't change that. But that's a good question. This load key command was the one I was talking about earlier, where you could create a session. And then we've got tools for MySQL, Postgres, where you can go in and basically say, I want to encrypt this database, or I want to encrypt this database in these files. And you can use wildcards to do that type of thing. Postgres is mostly about working with table spaces. On the MySQL side, actually on MySQL you have a couple of different options. One, you can just take that whole var live MySQL, and you can just encrypt everything. So everything's encrypted in that data storage, everything under it. And so you would see a link to our encrypted directory at that layer. And we have some customers that do that. Or you can do the layer where you use our command, and then we'll allow you to decide, I want particular tables, or I want particular databases encrypted or not. So, 6 1 half dozen the other. It depends on what sort of use case you have. Also, we create a MySQL logfile area, so you can take the bin log and you can encrypt the directory where the bin log goes, and then now your bin logs are protected. And then you can create other rules to allow bin log tools to either work on them or not. Really depends on what you're using them for, if you're log shipping or not. On MySQL replication, it doesn't affect it, because that's all, MySQL replication is all going through the MySQL transportation layer. So you should certainly use SSL or SSH on that to protect the data in transit. But that's it. You'll notice too, we've got a top command, so you can actually go in and watch what's being encrypted and decrypted in real time. Wouldn't be very exciting right now because I don't run anything on it, but when you're in production mode, that's kind of cool. And then update module, so anytime you update the kernel module, you just run this command, and it'll flip a new kernel module to map to that. Because every time you flip a merged kernel module, virtual file systems have to have little tweaks, so we make it real easy to do that. So one of the things I was going to show was I've got a directory here called MySQL Backup. And so I've got that, and I've got another directory called Protect. So if I go into Protect, there we go. So say I wanted to do a MySQL backup, and I wanted an operator to be able to run it, and I didn't want them to know the username and password in MySQL. Then I could create a configuration file with user equals root, password equals Gazzang, and some sort of result file. All right, and you can run the MySQL dump command with dash extra configuration file, I forget the exact name, and you can point it to this configuration file. So what I can do is basically I can say easy encrypt dash dash encrypt at see if I get the alright, there we go. And I have to run this as root. So basically it's going to go in there. So now that's and this supports the concept of an encrypted directory. So any file that goes in the encrypted directory is encrypted. So right now there's no files in that backup directory. And then I would go and encrypt that protect directory. So now I've got two directories that are encrypted, and they're using this name, this @MySQL backup, as sort of the tag for where it is. So now I can create an access control. So I've got MySQL dump. So if I want to give MySQL dump permission to that, then I would do a easy encrypt. So access control, and I'm going to do an add, and I'm going to say allow add. So allow into this MySQL backup, and I'm going to say I can actually limit rules to sections within an encrypted directory. So I'm going to say just everything, and then I'm going to say user bin.
You have to run this again when you upgrade MySQL dump.
Hold on, passphrase. Okay, so I just added a rule to the system that's going to allow that. What was your question?
Sorry, do you have to run this again when you upgrade MySQL dump?
No, you actually would do there's a command that we just say update, so that it'll go in and it'll create new SHA 256 hashes, so that when you do it, so and I'll show you how you see that, or one way to see that. So basically, I just listed out all my rules. So these are the rules that get created. And these first two rules got created when we ran our little configuration wizard tool that I'm not showing, but it basically finds where all the MySQL stuff is, and then it says, do you want to create rules? And then it does basically what I just showed you for MySQL dump. So that's sort of how we map processes to categories of data. And then for MySQL dump now, I don't know if I can remember the MySQL dump dash extra, but basically I would run the MySQL dump. Maybe if I run it, it'll tell me all the parameters, and then I can, options. It is that darn thing. Oh, here it is up here. It's, you remember what it is, Sherry? It's like extra. I should have written that down. It's like extra for the extra configuration file.
I think it's not default file. I think it's just config file. Do it like on MySQL help type in a grep for file. I think it's called config file extra.
Yeah, I think
File.
it's. Yeah, okay, so extra.
Default's extra file.
Yeah.
Right, because it's the.
Yeah, so basically then I would run a MySQL dump. Can switch between Mac mode, and then what was that file name? Well, so anyway, I can't remember what opinion, but basically you go through, you could reference that extra file, and you could do that. Now the shortcoming of this one, and I wrote this blog, and then a smart guy emailed me back and said, that's clever, but you forgot that I can override parameters on the command line for MySQL dump and redirect the results file. So we're doing some more things. So let me get back to my slides, and I'll sort of talk through some more scenarios, and also talk through how we solve the problem of controlling scripts and trust around scripts that are doing things for MySQL. So I just showed you, sort of, these are sort of the commands I would use for MySQL to encrypt an employee's database or certain tables within it. And again, there's a decrypt for all these things, so you can just decrypt them. NODB, you can either do all the files, or you sort of put it in use that NODB file per table mode, and then you can pick individual tables to encrypt. So I think that probably makes a lot of sense to folks. Or I see I did my demo too early. So here's where I go through what I just did in the demo about protecting MySQL dump files. So again, I would basically do it defaults extra protected login.cff, and then maybe all databases or something like that, so I could mix and match that. So basically, once I've got this set up on the system, it's sort of going to look like this, where I've got different directories mapped into sort of encrypted pockets, and then are mapped to the process that I have. The other cool thing you can do too is you can do cascading trusts. And so, for example, we have a customer that actually encrypted their JVM so that it could be only trusted and run from Tomcat. And then they encrypted actually some of the jar files for their JVM that were referenced on that. And so what you end up doing is you actually use that set session thing I was talking about earlier, and you use that so that you set a normal session, and you can set an access control on something that's encrypted, and then it goes through and it loops through the whole path. So you can really make things very secure, and you can sort of do some interesting logic with that. The other thing too is that if you're sharing files across multiple servers, then you can still have this concept of virtual transparent encryption across many things, so that if you're sharing onto a SAN or something like that, those files can still be encrypted on the SAN, but only the particular servers you've given key access to can get to that. Or like for moving and restoring backups, right? So I can, again, if I'm sharing the same key, if I set the same access controls, I can transparently encrypt and decrypt that data on multiple systems. And in the case of MySQL encryption I'm showing here, MySQL replication doesn't really care. It's really doing that above at the top level, but I can still secure all those files down below just fine. But in the case, you could use same passphrases, different passphrases. Maybe there's some reason you would want to use different ones on a slave than a master. I can't, I can't really think of, well, I suppose I could think of why, but we could probably come up with some reason. If you were using something like Tungsten or some other tool, right, they work a little bit different. So these are cases where these things are reading the bin log files. They're not reading it through the MySQL replication protocol. So it could be the case where all that data is encrypted, those bin log files are encrypted. You would just create a rule for that Tungsten Java process to be able to read those files and then be able to read and write them on the other side. So it's sort of, you mirror the thing up. So just some of the use cases about what some of our customers are doing. I think it's always nice to sort of see, who's doing things. We had this one customer, and I sort of talked about this earlier. They had an interesting situation. They were dealing with a bunch of very, very, very proprietary financial information for their customers, and they're a SaaS play. And they got a big customer come in and said, "This has to be so secure. You guys cannot lose our data. Bad things will happen." And so they came to us, and they needed to encrypt the MySQL data, usernames, passwords. They were in a managed environment. So they're the company running the SaaS stuff, but vertically they had this other company running backups and doing Linux administration stuff. And then they have their customer coming in from the other side. So you really got a more complicated access control story. So they needed to protect that. They needed to protect their byte codes. They needed to protect their properties files that had usernames and passwords in there. They had data coming in from this customer in XML and other document files through a VSFTP server, but that customer wouldn't even let them persist that data on disk in a transient fashion on Linux. And so, VSFTP is secure on the network side, but it still writes the data in whatever format it is on disk. So they needed that to be encrypted, and they needed to have a process that could read those encrypted files and load it into MySQL. So again, it gets complicated in how you do these type of things. So we had somebody, do a pretty novel solution to bring that all together, and it helped them do a lot more business. Lots of folks are doing financial planning out there. Their SaaS solutions. None of us wants our personal data getting out. Again, these things are being built with MySQL. So, protecting individuals' secure financial data, doing currency management, right? If you're doing anything like that, you don't want that data getting out. It's sensitive. On the mobile platforms, we've even had folks that have needed to create applications where their service is talking out to their mobile application. It's healthcare data. None of that data can ever be written on the mobile application or on the server together. They combined some solutions with some key management across both the mobile and the backend server, so they could do that type of thing and really enhance it. And they had all the things. They had PCI, HIPAA, FSMA, and ISO 9001 requirements. All of those requirements they had to meet. So pretty complicated. Medical research, and I was actually here meeting with some folks using our system here today. medical research gathers terabytes and terabytes of data that would be very hard to write, you know, encryption at the column level. And so this is a way to protect it up. And you know, you still have to make sure your grants are good. You still have to control all those type of things. But we've seen a lot of success in that area. Online expense reports come in with credit card data in it. And especially, this isn't as big of a problem in the sort of consumer to business, but there's a lot more B2B type stuff going on. And there's actually a lot more exposed information in these sort of B2B protocols than there are in consumer to business. So that can be a big challenge. So those are some of the things we're seeing out there. Protection, and on the European side, I think there's some new things starting up. So if you're doing any data in Europe, the EU privacy controls are quite tight as well. So another thing to consider if you're expanding your business outside the United States and going into Europe. Particular about where keys get managed and things like that. And we allow these key stores to be either located in our hosting environment, or they can actually run the key server wherever they are. So in the case of some of these medical ones, they're running their own key servers. In the case of Europeans, they'll run theirs over in Europe, data centers, not in data centers here. So I've got a sort of an extra release, a little cool idea, and something to sort of think about that will be coming out within 2 or 3 weeks. And I don't know if it's geeky excitement for me. It's not, may not be that exciting. But there are some particular challenges around protecting scripts. And one example is MySQL D_safe is a script, right? Now, sometimes it will issue commands in certain situations where you don't have the configuration set up a certain way. It'll issue commands like df or things like that. Now, right now we won't allow those to run, and our customers will just go in and add one line to the configuration file and it works just fine. Which, you know, so there's a simple workaround for that. But what if I could create a way where I could really trust scripts, where I could monitor scripts, make sure they don't change, but where the script doesn't necessarily get access to the encrypted data, just the process. And so we're looking at a thing like here where I'm saying, you know, MySQL D_safe is trusted if it's executed from dash. So I'm saying what sort of shell is it? And then I'm saying, and here are the following children that I'll trust underneath that. And so it could be bindf. In this case, I don't have MySQL D listed, but I think we could even, you know, list out things like that, where things that are trusted from scripts. So now we can create trusted scripts that can do things on systems that if they get tainted will not work anymore. So we can sort of keep more control of that. Another interesting one is Cassandra, or anything that's running as Java. So Java, right, it's a virtual machine. It's not really the same as running an executable. And so in the case of something like Java, I have a script that runs, that kicks off one of the longest Java class path things you'll ever see. That should only be that way. And then it needs access to some sort of you know, bar live Cassandra data or wherever you've configured it to go. So now I can say, well, that bash script that executes Cassandra can have a child Java that can, you know, read and write encrypted data to that. And so I can create the concept of this Cassandra script actually being a trusted executable, and that it can't be changed or tainted. And you can see where that could go to other places where you could protect authentication files and all types of stuff like that. So that's sort of our new thing, this concept of a sort of a parent, a child, and being able to secure down scripts, or being able to secure things like something like Java, or something that's interpreted language type of thing. Well, so I hope, you know, that in this talk I've sort of let you see some of the things that you can do with transparent encryption that you may not have thought of before. You've seen sort of transparent data encryption embedded in other products, but this is really more of a framework like a firewall, but really for processes and data where you can go out and protect your Linux data. And I think, one of the biggest fears in the cloud and stuff like that, and these more managed environments and SaaS environments, is really data protection. And this is really, I hope is one of the solutions towards that. Any questions, comments? Yes?
Does it work with Oracle Linux?
Huh?
Does it work with Oracle Linux?
Yes, it does, because it supports that kernel, and Oracle Enterprise Linux
Yes,
is
the other
supported.
regular kernel too?
Yeah, yeah, we've tested on that, it works.
Can you repeat the question?
Question was, does it work with Oracle Linux?
Yeah, yeah.
Which is a-
So Easy Encrypt
It's a variation
will
of
work
Red
with
Hat.
Oracle Enterprise
Right.
Linux. Yeah.
And how do you license the technology?
So the technology is licensed per server.
Okay.
It's on a subscription basis. For databases, it's $500 a year. For the Flex license, where you can do anything, it's $1,000 per year.
That include physical and virtual servers?
We just count servers themselves, so we don't count, and we don't count size of server, we just,
Server.
a server's a server, whether virtual or physical. Yes, sir.
What do you guys see as your competitors? What do you guys see as your competitors?
No, there's some more HSM appliance-like devices out there that do some of this type of thing. But we really, the main thing we run into is really the person that's trying to write it on their own. But there are some appliance-based things that are really doing key management, and then they do some file system things. They don't do it the same way we do. But there are a couple out there. Yes?
So, so it's a kernel module, and basically you have a file that's on an existing X file system or something like that, and the kernel module is kind of like in a loopback fashion. I'm just asking.
Yeah, I'm just trying to,
Yeah,
it's a little hard to hear you, sorry.
So essentially, like, what it sounds like is that you have kind of a kernel module that's loading like a particular file system within a file, right? So then, is it a matter of like, and then you're having symlinks?
Yeah, so so the virtual file system is really sitting on top of the physical file system.
Right.
So I could actually drill down farther, and I could show you where all the physical files are on that Linux server,
Okay.
and you can see them, that they're all AES 256
Right.
encrypted, and so we're layering a virtual file system mount
Yep.
on top of that file system. So if you do a DF, you'll see it. That's a good question. Yes.
Playing devil's advocate a little bit.
Okay.
If I know I saw from your demo that root can't necessarily run an LS on the stuff that's encrypted unless you specifically give root access to do that.
Mm-hmm.
But the key is still, it's a little cached in RAM. So if root can get a dump of memory, they might be able to find the encrypted keys in there.
Yeah. So at some layer, you could do that, and that's where. So.
Well, if they break into root on your machine,
Yeah, you're.
game over anyway, right? They could restart MySQL with no grants, with skip grant options. They can.
But they couldn't if the data is on.
When
If
you
the data is in a blob that's encrypted with a key that you don't have, you have to have a key in order to get to
Right.
that blob data.
So if you don't cache it in RAM and just rely on the offsite thing being up all the time, then you could even protect against root compromise, but it'd just be a pain in the ass if the network went down.
Right. Well, yeah.
Yeah.
Yeah. So if you really got compromised on root, theoretically you could find it that way. The solution that we have to solve that is that we also we integrate with the OpenSSL engine, and so and we support PKI, and we support RSA keys, and so and then there's lots of HSMs that support that OpenSSL engine methodology. And so we have some customers that do have that layer of worry about protecting it. And so those customers will go to a solution where you'll use an HSM to provision out the PIM file, the RSA key for those. And so, if you need to go to that sort of HSM level, FIPS 140-2 or the new one -3, then you could do that. But that's hard to do inside a cloud server. So Yeah, that's a very good question. Yeah.
I guess if I could ask a follow-up.
Okay.
As far as HIPAA regulations or PCI, do you have a sense that kind of the world will accept the solution as is without that HSM physical add-on stuff?
Yeah, we've gone through multiple audits with customers with the solution, and yeah, this will pass on that. Yeah, and we apply mostly that 3.5 and 3.6 section of PCI, where it's about key control and access control management. And there's another section that folks don't usually write up for us, but that they could, about limiting access control more so in the PCI spec. Yes?
This is probably a silly question, but so this is a very Linux oriented. I was just wondering if you guys were ever thinking about going towards FreeBSD or any other platforms for this type of technology, or it's obviously pretty baked into the Linux kernel.
Yeah, you know, right now we're just on Linux,
Yeah.
but you know, we are considering other systems. A lot of folks ask for Windows too. I know how we would write it, but you know, right now we're just staying focused on the Linux systems, and we support quite a few of those right now.
Okay.
But I think they'll certainly be doable. Yeah. How many of you guys implement encryption in some sort of way inside your environments? You do.
Yeah.
Like at the application level, or inside at MySQL, or
Right now, basically what I'm doing is I'm just putting it doesn't do, excuse me, what this does. I'm just having a partition which is at the operating system file level. So if it's a live system, then yeah, you could get it and just copy the files. But you know, it's doing a couple different ones. Like one of the Linux file system based.
Right.
So I mean, the problem really is access. Like if someone can get in that machine, they're going to be, you know, they can get there. Now, if the system was off and they just full of disks, they need the passwords to get in there. You know, it's not the same level.
right. Okay, I'll stick around for a while if you guys have any more questions. Thanks for having me, and it's been a great audience. Thank you.